In this video, Maui Surf Company creates surfboards at two different locations, in Lahaina and in Hana, both of which are in Maui. And it ships those surfboards off to two different beaches also on Maui, Kaanapali Beach and Hukipa Beach. So what I like to do to get these types of problems started is to create a diagram. And so I've already started the diagram here. And so what we're going to do is we know that we have some surfboards going from Lahaina to Kaanapali. I'm going to switch colors here. We'll do this in purple. And so let's say that the number of surfboards shipped from here to here is X. And the number of surfboards going from Lahaina over to Hukipa, let's let that be equal to Y. And let's do in green, the number of surfboards going from Hana to Kaanapali, let's let that be equal to Z. And if we let the number of surfboards from Hana to Hukipa be W. So this is where we can get started. So we're basically identifying, by use of a variable, the number of surfboards going from one place to another. Now, let's show that we have, that in Lahaina, it says they can make 180 surfboards. So I'm just going to put 180 up here. Kaanapali, Hana can make 150 surfboards, so I'm going to put that number up there. That's how many Hana can make. Kaanapali Beach orders 190, so we want 190 going down here. And it looks like Hukipa has 140. All right, so that information is going to get us our first 4 equations. So let's just scroll here a little bit. To come up with the equations, what we want to do is say, okay, from Lahaina, we know we have leaving there X and Y. And the total of X and Y has to be equal to the 180. So my first equation is X plus Y equals 180. From Hana, we have 150 surfboards, and they're going via Z and W. So we can say that Z plus W is equal to 150. Likewise, Kaanapali is ordering 190, and they are coming from X and Z, are coming into Kaanapali. So X plus Z has to be equal to 190. And then finally, Hukipa, 140. They are coming in via Y and W. So Y plus W is equal to 140. So there are our first 4 equations, but we have one more equation, and for that I need to go scroll back up just a little bit. And this is the cost equation. And let's do the cost equation in orange. So there's a cost for transportation for each. It says transportation budget is $48.90. So the most we can spend is $48.90. And from Lahaina to Kaanapali is $7. So this right here has to be multiplied by 7. So we would have 7 times X. From Lahaina to Hukipa is 13. So that means we would have to multiply Y by 13. From Hana to Kaanapali, that's my Z, That's going to be multiplied by 23. So that would be 23 times Z. And then finally, from Hana to Hukipa is 17. So that is W, and that has to be multiplied by 17. All right, those are the equations that you need to set up to do this problem. The rest of the problem is creating an augmented matrix and using Gauss-Jordan elimination to reduce that matrix. So I would encourage you to see if you can do that. So you might want to stop this video, go through and see if you can do it, and then start the video up again. All right, so let's create our augmented matrix from these 4 equations. So we're going to have an X column, a Y column, a Z column, and a W column, and then the constant column in our matrix. So let's start with the first equation. X plus Y equals 180. Well, that's 1x plus 1y is equal to the constant 180. The next one, 1z plus 1w equals 150. Our next equation, we have 1x, 1z equals 190. And then finally, 1y plus 1w equals 140. And our fifth equation then, we have 7x, 13y, 23z, 17w, and 4890 for the constant. And that is our augmented matrix. All we have to do is fill in the zeros. Anywhere we don't have a number, it will be a 0. Now what we want to do is to reduce this to reduced row echelon form. And so to do that, we want to start in the upper left-hand corner, and we want a 1 in this position. Well, we have a 1 in that position. I sometimes like to refer to that as my pivot. We want a 1 there, so we have that. That's great. Then what we need is we need every entry below that 1 to be a 0. So we need to get rid of this 1 right here, and we need to get rid of that that 7. We need to make those into zeros. And so to do that, we have to use row operations. So what I like to do is rewrite the rows that I'm not going to change. So I'm not going to change row 1. And let's do this in blue. So row 1 is going to stay 1, 1, 0, 0, 180. Row 2 has a 0 in it already, so let's just keep that. 0, 0, 1, 1, 150. Now we need to change this 1 into this one right here, into a 0. And so we could simply add row 1 to row 3. But I'm going to do that with a negative. What I'm going to do is I'm going to write my row operation up here. Negative row 1 plus row 3 is going to replace row 3. And so negative 1 plus 1 is 0. In the second column, we have a negative 1 plus 0 is a negative 1. In the third column, we have a negative 0 is 0 plus 1 is 1. and then a 0 plus 0 is 0. And then a negative 180 plus 190 would be 10. The next row is not going to change. Row 4, that stays 0, 1, 0, 1, 140. And then finally, my last row, I need to make this 7 into a 0 using my pivot number, which is the 1 again. So to do that, and that looks like it's a negative, it's not really. So I'm going to do negative 7 times row 1 plus row 5 replaces row 5. You have to forgive me, I have a really bad stylus. So negative 7 times 1 is a negative 7 plus 7 is 0. Going to column 2, negative 7 times 1 is a negative 7 plus 13 is 6. And going to row 3, we have negative 7 times 0 is 0 plus 23 is 23. And then the next column, we're going to have 17. And then a negative 7 times 180 plus 4890 ends up being 3630. 3,630. And there is my new matrix. Now notice that in the new matrix, just as we want, we have a 1 here with all zeros underneath. That's what we're aiming for. Now what we need to do is we need to get a 1. We need to go down 1 and over 1. So we want to go down 1 and over 1 to this position. That needs to be a 1, but it's a 0. So what I think the best thing to do here would be is to switch 2 rows. I think what I'm going to do is take row 2 and row 4 and interchange them. Row 2 interchange with row 4. And so what that's going to look like is, first of all, let's rewrite what's not changing. Row 1 is not changing. Row 1 is going to be 1, 1, 0, 0, 180. Row 2 and row 4 are changing, so row 4 is coming up, and that's going to be now 0, 1, 0, 1, 140. Row 3 is staying the same, 0, negative 1, 1, 0, 10. Row 4 is now row 2, 0, 0, 1, 1, 150. And then finally row 5. And there is our next matrix. All right, so we've got the pivot that we want, which is this. This is my pivot. That is my 1. Everything else in that column needs to be a 0. So we have 3 numbers we need to get rid of. We need to change this number right here, this number right here, and this number right here into zeros. And so the way I'm going to do that using my pivot is, once again, I'm going to take negative row 2 plus row 1 to change row 1. So let's see how that's going to work. So negative row 2 plus row 1 is replacing row 1. So in the first column, a negative 0 is 0 plus 1 is 1. And then in the second column, a negative 1 plus 1 is 0. 0, and then we're going to have a negative 1, and a negative 140 plus 180 would be 40. To get rid of this number right here, all we have to do is take row 2, add it to row 3. And that's going to replace row 3. So 0 plus, we want to make sure that we rewrite the second row, because that's not changing. Row 3 then becomes 0, 0, 1, 1, and 140 plus 10 is 150. Row 4. Well, row 4 looks good. We've got a 0 right where we want it. So I'm simply going to rewrite row 4. Row 5, need to get rid of the 6. So it looks like if I take negative 6 row 2 plus row 5, I can replace row 5. So we're going to end up with a 0 here. A negative 6 times 1 is a negative 6 plus 6 is 0. Negative 6 times 0 is 0 plus 23. And a negative 6 times 1 is a negative 6 plus 17 is 11. And a negative 6 times 140, I guess we're going to have to figure out what that is. So 140 times 6 is a negative 840 plus 3630 is 2790. And I'm just going to double check my math on that. So negative 6 all right. And there is our next matrix. Now we move on to column 3. Only 2 items to change in column 3. This is now my pivot. Again, we go down 1 and over 1, and we need to remove this and this. So I'm simply going to take row 3 plus row 4, or the negative of row 3 rather, plus row 4 replaces row 4. Row 1 will not change. Row 2 is not changing. Row 3, my pivot row, is not changing. Row 4 now, we can change. So I have a 0, 0, 0, and another 0, and another 0. Wow, we have a row filled with zeros. Now, don't worry about that. If this was a linear algebra class, we would go into more depth as to what exactly is going on here. But we need to have a row of all zeros in this problem. So that's a good thing. If you end up with a row of zeros, just say to yourself, good job. Now, we also need to get rid of the 23. So negative 23 row 3 plus row 5 is going to replace row 5. So we're going to end up with a 0, a 0, a 0. And let's see, negative 23 times 1 is a negative 23 plus 11 is a negative 12. And calculator time again. Negative 23. Negative 23 times 150 is 3450 plus 2790 is negative 660. All right. There's our next matrix. We're getting there. We move on to column 4. But before I even do that, I'm going to simplify that last row a little bit. If I was to take row 5 and multiply it by the reciprocal of the 12, negative 1/12 row 5, let's just see what that's going to do for us. Now, the last row is simply going to become 0, 0, 0, 1, and 55. So that simplifies that last row a little bit. So I'm going to rewrite the matrix real quick. 1, 0, 0, negative 1, 40, 0, 1, 0, 1, 140, 0, 0, 1, 1, 150, 0, 0, 0, 0, 0, and then finally 0, 0, 0, 1, 55. And finally, let's get rid of all those ones in column 4. So this is my pivot now. And we need to get rid of this, this, and this. So it looks like if I simply take row 5 plus row 1 and replace row 1, I will have 1, 0, 0, 0, and 55 plus 40 is 95. And we then want to take negative row 5 plus row 2, replacing row 2. So we will end up with a 0, 1, 0, 0. And a negative 55 plus 40 is going to give me, what, 85. And now we want to do negative row 5 plus row 3 replaces row 3. And so we will have 0, 0, 1, 0, and negative 55 plus 150 would be 95. And then we have our row of zeros. And then we have our pivot row. And we are done. We are now in reduced row echelon form. If you take a look at this matrix from here to here, you have the identity matrix. All ones and zeros with the main diagonal being a 1, and then you have your column of constants. So remember that this is my X column, my Y column, my Z column, and my W column. So what this tells me is I have 1X equals 95. I have 1Y equals 85, 1z equals 95, and w equals 55. And those would be our answers, assuming we didn't make any silly arithmetic mistakes. All right, hope you enjoyed this video. It was a long one, and if you have any comments, please let me know.